Hello again. In this video, I will be solving two examples related to energy stored in a capacitor. They will not be really that complex. They're simple just to give you the flavor of how we can use different forms of the energy stored in a capacitor. So first one, a camera flash uses a 110 microfarad capacitor to store energy for its flash. If the voltage across the capacitor is 330 volt, then how much energy is stored in the capacitor? So what we have here, I have capacitance 110 microfarad, and I have the voltage, it is 330 volt, and I need to know how much is the energy stored in a capacitor. So we remember in our previous video we mentioned that there is different forms to write or to calculate the energy stored in a capacitor, and the one we decide to use depends on what is given in the question. So in this case I have the capacitance and I have the voltage, so I will choose that it is half the capacitance multiplied by the squared of the voltage, and simply we're just replacing the value. Multiplied by 330. Just doing some math and calculation. Okay, that should give us 6 joule. That will be the energy stored in this camera flash capacitor. Okay, so let's go to the next video, or sorry, the next question. It says an AED uses 450 joule of electrical energy to shock a human heart. These are the devices they use in the emergency room. Sorry, the energy is stored in a capacitor that is charged by a 4000 volt supply. 1. Determine the capacitance required to store this energy. Okay. Second, how much charge is stored on the plates. So it's a bit of a reverse procedure here. Now what I do have the potential energy stored in this capacitor, and I have the voltage, it is 4000 volt. For the first part of the question, asking for finding the capacitance, it is the C. So once again, I need to think about which formula of the potential energy or the stored energy in a capacitor will serve my need. You will find that if I apply the potential energy equal half CV square, okay, and after that I'm rearranging my formula, so the capacitance will equal 2 multiplies by the potential energy divided on the squared voltage. It will be 2 times 450 divided 4000 square. That should give us the value of 5.62 10 to the power minus 5 farad. So that's the capacitance required or need to be used in this device. Now for the second part, I can answer this one here, should be enough. It's asking how much is the charge stored in the plates. Well, Now I have the capacitance, I have the voltage, so I can say, all right, it's the charge equal the capacitance multiplied by the voltage. Now it is 5.62 10 to the power minus 5 multiplied by 4,000, and that should give us 0.225 coulomb. The amount of charge will be stored on the plates of this capacitor. So I hope you find these examples useful. They're simple, straightforward, just to give you the feeling of how you can choose and use the energy stored in a capacitor formula. Thank you.